Hello friends, today the topic that we are going to study is power. What is power? Power is nothing but the rate of doing work. We have already studied what is power in the previous lecture, in which we have calculated the work done for a block moving on an inclined plane or a block moving on a horizontal plane, and the third we have seen is when the block comes in contact with a spring. Now work power is equal to work done per unit time, or it is nothing but rate of doing work. Now this work done can also be expressed as the product of force multiplied by displacement. So we can express power as force multiplied by displacement upon time. Now this power can also be written as force multiplied by velocity, or power can also be expressed as the product of force multiplied by velocity. Now this term displacement upon time can also be written as velocity. So power can be written as force multiplied by velocity. Now coming to the unit of power, force will have a unit of newtons and velocity will have a unit of meter per second. So power will have the unit Newton meter per second. Now this Newton meter per second is nothing but equal to joule. So we can write power as or power can be expressed in terms of joule per second. So there are two ways in which we can define power. One is power is the rate of doing work or work done per unit time, and secondly it is the product of force multiplied by velocity. Now what are the applications that we have to study for the term power? Power is, we are going to study the power related to engine or the power related to a train. So the train will comprise of an engine, and the engine will be attached with the help of wagons or bogies. So we have to find out how much is the power required to drive a train. Now this train will be moving on three surfaces. One is it will be moving on a level track. So the train will be moving on a level track or a horizontal surface. Second is train will move up the incline, or the train will climb certain incline. And the second one will the train will move down the incline, or the train will be moving downward. So these are the three possibilities which we are going to study, in which we are supposed to find out the power. Now in all the three cases the force required will be different. Now we have seen this power is equal to rate of doing work, or power is equal to force multiplied by velocity. Now here, while calculating the term power, we are going to replace this term force by total resisting force. So the power will be equal to total resisting force multiplied by velocity. Now this total resisting force will be different for level track. It will be different when the train is moving up the incline, and the total resisting force will be different when the train will be moving down the incline. So this total resisting force comprises of, so this power, total resisting force multiplied by velocity, or we write it as TRF in short form. This is not a standard notation, but we can write it as TRF. Now this total resisting force includes four types of forces. One is resistance due to friction, or which is called as tractive resistance. In short, it is written as TR. Now what is this? When the train will be moving on a level track or on any inclined surface, there will be contact between the wheels of the train and the surface or the track. This is called as track. So there will be a contact between the wheels and the track. So there will be a friction produced in these two. So that is nothing but called as resistance due to friction or tractive resistance. Tractive resistance means resistance between the track and the wheels. So that is called as tractive resistance. Second is force required for acceleration. So to move the train, we will require certain acceleration. So the force required for that is equal to Fa is equal to m into a. So force required for acceleration is given as Fa, which is equal to m into a, where m stands for the mass of the train. The mass of the train means it will be the mass of the engine plus mass of the wagons, or sometimes it will be simply mass of the engine if the engine is only moving on the track. And A stands for acceleration. Then next is air resistance. So the train has to also overcome the additional force will be required for the train to overcome the air. So additional or wind force. So that is called as air resistance. So air resistance is nothing but AR. There is no standard formula to calculate air resistance, but certain relation may be given for air resistance. So based upon that relation, we have to find out the value of AR. And the fourth one is resistance due to inclination. This resistance due to inclination is given as Ri is equal to mg sin alpha, and it is resistance due to inclination. So when the train is moving up the incline, or it is moving up the incline, the train is moving up the incline or the train is moving down the incline, then only this resistance due to inclination will come into picture, because Ri will be equal to what? Mg sin alpha. It is the component of weight along the direction of motion of the train. Component of train along the direction of motion. So if we consider this train, it will be having a vertical, it will be having a weight W. So we are going to resolve this weight into its two components. So this component will be mg sin alpha, and this will become mg cos alpha. So it is a component, this component, horizontal component of weight, which will be acting. So that is nothing but resistance due to inclination, which will be equal to Ri is equal to mg sin alpha. But this will come only when the train is moving up the incline or down the incline. Along the horizontal surface, this resistance due to inclination will not come. So for all the three cases, let us find out what will be the total resisting force. So on a level track, the total resisting force is a combination of tractive resistance plus force required for acceleration plus air resistance. Next is on a level track, or when the train is moving up the incline. In that case, the total resisting force is a combination of tractive resistance plus force required for acceleration plus air resistance plus resistance due to inclination. Now, when the train is moving up the incline, the resistance due to inclination will be added, because it is the additional force, because it is moving against gravity. So that's why it will require additional force, that is Ri. So it is here plus. Now when we calculate the total resisting force on an inclined plane, when it is moving down the incline, in that case we don't write it as total resisting force, we write it as net resisting force, because here the resistance due to inclination is subtracted, because it is moving towards gravity. So this force will be subtracted. So this formula is same for up the incline and down the incline. Simply here it is plus and here it is minus. So here this is how we calculate net resisting force. Now it is not necessary that all these four forces will be present in all the numericals. So based upon the data that is given, we have to calculate these forces. So this is how we calculate the net resisting force, or the total resisting force on a level track, up an incline and down an incline. Then last thing is we have to calculate efficiency. Efficiency is equal to power output upon power input multiplied by 100. So whatever power we are going to calculate, so from this we are going to get a net resisting force, or TRF. So once we get this value, total resisting force, we will multiply this by the velocity, and from that we will get this power. Now this power is what we calculate, and that is nothing but equal to power output. So efficiency is equal to power output upon power input multiplied by 100. So sometimes we are supposed to calculate the actual power also. So whatever power we are calculating here, it is called as power output. Once power output is known and efficiency is known, we can find out the power input, which is nothing but equal to actual power required. So these are some of the formulas that are useful to find out the power required for a train. I hope this is clear to you.